Okay, guys, here we have a question, which is, I think, a good question to practice tree diagrams. We're going to do this question in two different cases, without and with replacement. Okay, so let's read the question together. A box contains 7 red balls and 3 green balls. 2 balls are drawn one after another, without or with replacement. So once we're going to do it without replacement, another time we're going to do it with replacement. Okay, find the probability of both are red. Both balls are going to be red, and find the probability that the first ball is going to be green given that the second ball is red. So I think it's a good question, especially because it also helps us to practice conditional probability. I'm going to take color red and I'm going to solve this question for without replacement. What does it mean without replacement? I draw a ball, I look at the result, I put it outside, and I go for choosing the second ball. Okay, so let's suppose that the first ball is red or the first ball is green. What is the probability that the first ball is red? It's going to be 7 out of 10. 7 balls out of 10 balls. And what is the probability that the first ball is going to be green? It's going to be 3 over 10. Now, let's talk about the case that the first ball is red. If the first ball is red, what is the probability that the second ball is going to be red? So remember, we are doing this experiment without replacement. So now I have only 6 balls left out of 9 balls. Okay. And what is the probability that the second ball is going to be green? 3 balls out of 9, because, okay, the first ball is red, but I still have 3 green balls out of the total number, which is 9. Now let's talk about the second ball red and the second ball green in the case that the first ball is green. So the second ball is going to be red. Its probability is going to be 7 out of 9. Why 7 out of 9? Because if the first ball is green, I still have 7 red balls left. And the probability of the second ball green is going to be now 2 out of 9, because one ball red, one green ball was left outside. Okay, just something to pay attention, that the probability of every branch, like these two branches, are going to be always equal to 1. Okay, this is something to notice. So 7 over 10 plus 3 over 10 equals to 1, or 6 over 9 plus 3 over 9 equals to 1. Okay, so this is the experiment without replacement. Okay, without. Now, what is the first case? Let's summarize it. The first case is the first ball is red and the second ball is red. Okay. The second case is the first ball is red and the second ball is green. You can continue like the third case is the first ball is green and the second ball is red. And the last case is both are green, 1 green and 2 green. Okay. In order to find the probability of each case, I just need to multiply the branches by each other. So for example, for 2 reds, it's 2 red balls is 7 over 10 times 6 over 9. For 1 red and 2 green is 7 over 10 times 3 over 9. For 2 green is 3 over 10 over 2 over 9. And the last case, or the third, is 3 over 10 times 7 over 9. Okay, these are 4 different outcomes. 2 red, 2 green balls. The first one red, the second one green. The first one green and the second one red. Okay, now let's answer the questions. What is the probability that both balls are going to be red? Well, obviously we are talking about the first case, so it's going to be 7 over 10 times 6 over 9. Okay, and what is the probability that the first ball is going to be green given that the second ball is going to be red? Okay, so let me write the rule. What is the probability that the first ball is going to be green given that the second ball is red? Can we write the formula? Isn't it like probability that the first ball is green and second ball red over the probability of second ball, red. Let me write the formula to recap. Probability of A given B equals to probability of A and B over probability of B. Okay, now I'm going to use this formula for both cases. Now let's do it for the case of without. So in this case, probability of one green and second one red equals to, let's write it here. Okay, so let's talk about the denominator. Can you tell me out of these four cases, in how many cases the second ball is red? Do you agree with me in the first and the third case, the second ball is red? Okay, only in these two cases. So 7 over 10 times 6 over 9 plus, remember it's a plus or, because we say case 1 or case 3. So we put a plus here, okay? Plus 3 over 10 times 7 over 9. Okay, this is the denominator. Why? Because this is red, and this is green and red. In both cases, the second ball is red. So this is our denominator. Probability of second ball is red. Okay, now what is going to be the nominator? Nominator, it has to be the first ball green and the second ball red. So we are talking about this case, 3 over 10 times 7 over 9. You can find the final answer with the calculator. I'm not going to do it here. Now I'm going to change the color. I'm going to choose color white, and I'm going to do this question with replacement. Okay, with replacement is much easier because the probabilities are going to be always the same. The probability of red is going to be always 7 over 10, and the probability of green is going to be 3 over 10 always. Okay, so here it's going to be 7 over 10 times 7 over 10, and here 7 over 10 times 3 over 10, 3 over 10 times 7 over 10, and 3 over 10 times 3 over 10. Okay, so if I ask you what is the probability of 2 red balls, it's going to be 7 over 10 times 7 over 10. And what is the probability of the first ball is going to green, given that the second ball is going to be red? Let me write it here. One more time. The white color is for the case of with replacement. So the denominator is 7 over 10 times 7 over 10 plus 3 over 10 times 7 over 10. Why? This is the case of red, and this is the case of green and red. The first one green and the second one red. What is the denominator? Nominator is going to be 3 over 10 times 7 over 10, because I'm interested in the case that the first ball is green and the second ball is red. And okay, so it's a very quick explanation of how to use tree diagram. Remember, here you have 2 colors, you can have 3 colors, you can choose 3 balls. Okay, the concept is literally the same. However, maybe your tree diagram is going to be a little bigger, but the concept, one more time, is literally the same thing. Thank you so much for watching this video. Thank you.